Let's add it to the top. That's 32. Let's add it to the darn, because we can't do this problem, everybody. Remember back to your parallelograms chapter. I think it's chapter 4 or chapter 5, way back when. Parallelograms, opposite sides are the same. If this is 20 inches, that's 20 inches. Even if they don't give that to you in the book, that's 20. Plus the bottom side. Oh, darn it. Oh, once again, shoot, how are we going to do this? They don't give us a whole side, they give us a partial side. So if this is 20, how do you figure that out? Well, you know, same thing. Opposite sides are congruent. That's 32. This is 32. It's going to do this. Total distance, 32. So add the sides of a parallelogram together. That's going to be 52. That's going to be 52. I think the perimeter is 104 inches. Perimeter is always in length. Inches, miles, feet, yards. You get the picture. Area. Okay, let's fill this figure in. Completely fill this in. Base times height. Okay, what's the base? Base. Well, you know, you could say that this is the base, 32, or you could say the bottom is the base. It doesn't really matter. They're the exact same thing. So base is 32 times the height. This is where kids fall apart. Right here. For some reason, I get kids that will say, yes, Mr. Kosal, I agree with you. That is the height. But then for some reason, they pick this 20 right here as the height. You get the base right here. They'll put 20 right here, and they're going to get a completely wrong answer. That is not perpendicular. This is the distance that you're going for. That is the height, ladies and gentlemen. And notice how they don't give that distance. Darn. Man, once again, I wish I could just look around my classroom and kind of see the puzzled looks on your faces and see if anybody has a hand raised. And I would say, who knows how to find the height? And then, you know, I'd pick somebody in the back or somebody on a certain side of the room. I don't know. Let's see. Well, first things first. That's 32. This is 20. I guess we can figure out that's 12 just by subtracting. You know, total side minus a partial side. That has to be 12. So if you're just looking at this right triangle here, you got a 12 right there for the bottom leg. You got 20 right there for the hypotenuse. And you want to find this leg. Folks, Pythagorean theorem. Pythagorean theorem all the way. X squared plus 12 squared equals 20 squared. A squared plus B squared equals C squared. Just please make sure that you use the two legs and you square them. The 20 is the hypotenuse, so that always ends up on the right side. X squared plus 12 squared equals 20 squared. Okay, 144. 20 times 20 is 400. Good. Alright, subtract 144 on both sides. Calculators, if you got them, get them out. I think it's 256. And then last but not least, to find x, square root both sides. And x is going to be 16. Square root of 256, everybody, is 16. There's your height. Let me go ahead and write that in. 16 is right there. That's what you need to find the area. And away we go, folks. Area equals, alright, 32 times 16. I got my calculator this time, folks. I didn't leave it in another room. 512. There's your answer. Please don't just circle that and move to the next problem. What's the label? Over here we got inches. With area, it's always going to be inches squared, or centimeters squared, or feet squared, or miles squared. Area is always square units. Perfect. All right. Example 2. Let's just find the area. I want you to find the area of the following two questions. Okay, find the area. Oh, there's going to be an A and there's going to be a B. Sorry, I couldn't avoid it. Let's go. Another parallelogram. Actually, they're both going to be parallelograms. Go ahead and get the second one drawn if you want. Sound effects are always welcome. Okay, let's come over here. Right angle. I'm going to tell you that this is 12. And that's going to be the whole base of the parallelogram. Just so you know, last problem I kind of did a partial base, but this is going to be the whole thing. And I'm not going to give you the height. I am, however, going to give you this side. I'm going to tell you that it is, oh gosh, what do I want? 9. And I'm going to tell you that this angle right here, everybody, is 45 degrees. That's it. That's all you get. Let's go ahead and find the area of this parallelogram. Oh gosh, a little more difficult than the last problem. Well, here's what we could do. We could start out by the area equation. And please make sure that you get the area equation right. Don't put 1/2 base times height. There's only one that's 1/2 base times height, and it's a triangle, everybody. It is a triangle. It is a triangle. Everything else is base times height. So, base times height. What do we have? Well, we got the base. I'm going to put it in parentheses. Base is 12. That's an easy one. Bam, right there. Height. No, it's not 9. No, it's not 9. You need it perpendicular. This is the height that you want. This is the distance, and as you can see, it's your unknown measure. However, there's a reason why I'm giving you this 45 degrees right here. Well, first things first, if this side of the parallelogram is 9, that means that the opposite side is also 9. Okay. Maybe somebody knows, maybe not. Good thing I taught everybody their special triangles way back when. If you have 45, 45, 90 triangle, here's a bit of a review, a blast from the past, so to speak. If this side is 17, remember that the two legs of a 45, 45, 90 triangle are the same. That would also be 17, and the hypotenuse is 17 root 2. I didn't even have to use the Pythagorean theorem. I know. And most of you also know your properties of your special 45, 45, 90 triangle. Just keep in mind that the legs are the same. Super important. Let's go down here really quick. What are the legs of this triangle? They're right here. These are the two legs of a 45, 45, 90 triangle. And I got my 45, I got my 90. This has to be 45 up here. It 100% has to be, because three angles have to add up to 180 degrees. So those are the two legs. Those have to be the same. And then this one is your hypotenuse. So the question is, how do we go back from the let me say this right, how do we go from the hypotenuse to one of the legs? We divide by the square root of 2. Remember, to go from a leg to a hypotenuse, you multiply by the square root of 2. But going from a hypotenuse back to a leg, you divide by the square root of 2. And that's exactly what we need to do. I need to divide by the square root of 2. So find a little bit of room with this problem. I need to take 9 and divide it by the square root of 2. And that's going to give me this height right here. If you remember back when we were still meeting in the classroom, I talked about this. You are never allowed to have a square root in the denominator. There's a certain way that you can get it out of the denominator, and that is by multiplying top and bottom by that square root. It's called rationalizing the denominator. It's called, in other words, simplifying the square root, so to speak. We're going to get 9 root 2 on the top. And on the bottom, let's see, we've got square root of 2 times square root of 2. Hey, that's the square root of 4. And that's a recognizable number right there, square root of 4, 2. So we got 9 root 2 all over 2. And most times you can simplify these numbers. You know, I wish the bottom number was, I don't know, a 3, because then you can say 3 goes into 9 3 times. But these don't simplify. That's your answer, and that's the leg of your 45, 45, 90 triangle. And this is also 9 root 2 all over 2. You really don't even need that. You just need the height. Speaking of which, here's the height. Okay. Area equals base times height. Let's multiply these together. We're done, folks. Oh boy, I don't know how to do that. Well, just put this over 1. Make it a fraction. That's going to be 12 over 1 times 9 root 2 all over 2. And you can just multiply tops together, bottoms together. I'm going to choose to cross cancel. Because 2 goes into 12 6 times. So that's going to be 6 over 1 times 9 root 2 all over 1. Multiply tops together, bottoms together. You're going to get area equals 54 root 2 over 1, but you really don't even need that. Okay, I mean, that's the area, folks. There's your answer. Units. Let's see, what are the units? What are they? Yeah, they didn't give us units. I didn't give you units. If they don't give you units in the book, you need to put units squared. Because it has to be square units. Centimeters squared, inches squared, miles squared. You guys get the idea. Over here. Let's give you the exact same thing. Let's say that the total is, just for simplicity's sake, I'm going to use the same exact thing. 12. Same base. And let's say you knew this side. Let's say it was, I don't know, 9. Let's use the exact same thing. What if this wasn't a 45, 45, 90 triangle? Let's say it was 74 degrees. Everybody, 74 degrees. And you had to find the area of that. You know, I could have used a 30, 60, 90 triangle here, but I wanted to use a different number. I want to see if you guys remember this. We need to find the height. You know, once again, I gotta find the area of this parallelogram. Area equals base times height. Base is 12. Height, I don't know. We need to figure it out. It's not 9, but we need to figure out the x. Does everybody remember how to solve for x on a right triangle like this? Gosh, I really wish you were in the classroom with me right now. I wish I could just look at your faces and see what you guys are all thinking. Does anybody remember SOHCAHTOA? SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Identify your opposite, your hypotenuse, and your adjacent, please. Let's see, this is your angle that we're working with. So your hypotenuse is right there. Your opposite's right there. Your adjacent's right there. So we are working with the opposite and the hypotenuse, I think. Not cosine, not tangent. We're working with the opposite, x. We're working with the hypotenuse, 9. Yeah, it's a sine. So folks, let's do this. It'd be the sine of 74 degrees equals the opposite, x, over the hypotenuse, 9. And if you have a calculator with you, you're going to want to get it, because you're going to need to use your calculators tonight in your homework. There's going to be some SOHCAHTOA, not everywhere, but just on a couple of questions, I think. Multiply by 9 on both sides. X equals, I'll just punch that in the calculator, so here we go. Alright, so 74, that's the sine of 74. If you remember doing this, punch out the sine of 74, you're going to get a very long decimal. Keep it in your calculator. Now multiply that number by 9. It equals, x equals 8.65. I'm not going to write them down. And I'm actually not going to round it, because I'm going to keep it in my calculator, because that's the height. And I want to find the area of the parallelogram, which is area equals base times height. So this is going to be your 8.65 ... and a whole lot of change. Keep all that change in your calculator and just take that height and multiply by the base. And you're done. Area equals 103. This is when you can round it. You know, the book might say round to the nearest tenth, nearest hundredth. Once again, unit squared. There you go. There you go. Last question. Example 3. Let's make it a word problem, shall we? Actually, you know what? No, I'm going to be nice to you guys. You guys have been awesome lately. Here's the homework. Page. Didn't expect that, did you? Page. Make sure I get you that page. 783. Let's do 10 to 15. 17 to 22. That's all I got for you, folks. Make sure I get this assignment by midnight. That's midnight tonight, which is Friday. And then you can enjoy your awesome, awesome weekend. We'll see you all on Monday. Take care.